Hello YouTube, De-bodgery here. So my first video I talked about readily available commercially made chargers, my little watt meter, XT60 or XT90 connectors rather, that kind of thing. In video 2 I talked about laptop PSUs being put together to make a DIY charger. You know, as long as you don't mind the 20 volt increments, they can be used as is, or get these HP 230 watt power supplies which can be taken apart pretty easily. And then I'll do a video on that at some point on how to modify these things so that you can adjust their output voltage. But yeah, these all switching power supplies can be adjusted. It's just that you know, a lot of things are from the factory at some set voltage. You just got to know what to adjust, and then the output voltage will adjust too. Okay, so the last thing I want to show you is the supercharger. So this is 3 projects all recombined together into one project. Only one of the 3 is at this point still working, and the other 2, well, one of them got the I'll get to this in a minute, but one of them got completely taken apart to put together like this, and then the third one I'll talk about that too. So right now this is an 82 volt charger. So the 2016, I guess it was, these 4 top power supplies I put together into an 82 volt charger. So I am using Meanwell SE600-24 power supplies. They are rated for 25 amps, but I know for a fact that you can get just short of 30 amps out of them, about 28-29 amps before they shut off. They are overload protected and thermally protected. They are electrically isolated input to output. The metal shell on the outside here is connected to the ground prong, the ground screw terminal on the AC side. So that's about as close as you get to some kind of electrical coupling between the AC side and the DC side. So this little terminal block right here, this is all the DC side, and there's a little pot that's up underneath here. It's kind of hard to see on each one of the power supplies for adjusting the output voltage. But these are 600 watt power supplies. So if you get, like this case, a 24 volt version, you're only going to get about 25 amps. Whereas like if you get the 5 volt version, you're going to get about 60 amps. But they're all still 600 watt power supplies. So the voltage adjusts, or not adjusts, but the voltage affects the amount of amperage that you're going to get. Anyway, these 24 volt ones, you can adjust them down to about 16 volts and up to about 32 volts. So they've got a fair bit of adjustability on them, which makes them fairly well suited for what I do with them. Okay, so right now, the top 4 here are my original charger, which I built in 2016 for 20S or 82 volts. So this is the lowest power supply in here. So that's from, you know, so this one is connected in series to this one, which is connected in series this one to this one. So, you know, low to high basically, so that I get my 82 volts. A little cheapy watt meter. It was fine for this, but once I tell you about all the rest of this, this watt meter is not going to cut it. This is a bank of 100 watt resistors. They are all in parallel with each other, and this little rocker switch right here bypasses them or puts them in circuit. So essentially what happens here is when you first start charging, keep in mind these are power supplies. They are not chargers per se. So when you reach their maximum limit, they don't limit current, they shut off. So you have to do current limiting some other way, and that's where these resistors are for. So with the switch off, all current flow has to flow through them to get to the EV. I don't have any EVs that won't charge at 30 amps. In fact, they will all charge it well over that. So anyway, I have to limit what happens here so that I don't, you know, turn my circuit. Sorry, so I don't turn my PSUs off. You know, they go into current overload and shut down. I want to keep them running continuously. So that's what the resistors do. They create some in-circuit losses so that the EV can't ever charge faster than, say, like 28 amps or so. After a while, I will notice that current draw starts dropping off, and this is probably about an hour after charging starts, or 2 hours maybe, depends on how large the battery pack is. And when it gets down to about like 6 or 7 amps, I will flip that switch, and now these resistors are all bypassed, and the output from the charger is direct to the EV. And then I'll immediately see current jump as well. And so for the remainder of the charge, the PSUs are delivering their 82 volts to the battery pack, and then the battery pack will eventually rise up to 82 volts. The charger just sits there on. Leave it that way overnight. I don't care. It's completely safe because it's only outputting 82 volts. These top four are right now anyway. So it's perfectly safe because it's not going to deliver 90 volts or 85 volts or something like that and overcharge the cells. It's only going to ever deliver 82 volts. So it's perfectly safe to leave it sitting on the battery pack overnight, completely unattended. No problem. All right, so that's how things are right now. The bottom four power supplies aren't effectively plugged in. All right, so I said that I did have 4 of these power supplies, another 3, and then I bought a last one, so like that one down there would probably be it. Really don't care which one it is. So they're all of different ages, but that's fine. Meanwell power supplies are exceedingly reliable. They will work the same way 15 years later as they do today. So what's going to happen long term to make this thing in the proper supercharger that it will be is this power supply will be in series with this one, which will be in series with this one, will be in series with this one, which will be in series with this one, and this one, and this one, and this one. So what this is going to effectively give me is from here to here, that's going to be 12S or 49.5 volts. From here to here, it's going to be 66 volts or 16S. From here to here will be 82 volts or 20S. From here to here, say, will be 24S or 98 volts. From here to here will be 28S or 114 volts. From here to here will be 32S or 131 volts, and from here to here will be 36S or what is that, 136 volts? So there will be a rotary switch that will switch in and out power supplies, both on the AC side and the DC side. So it'll just be a single rotary switch with basically 9 positions. Actually, it's got 10 positions on it, so that either at the one extreme or the other is off, essentially. And I already have that switch. So all the way one position extreme to the other position extreme, the whole thing was shut off. Position 1 will be those 2 power supplies, or 12S, and no other power supplies, in the 12S position on the rotary switch will get AC power. No point in having them powered up when they're not doing anything. So 16S or 66 volts, that'll be like the 3rd position on that switch. That'll apply AC to here, and it'll also change the output. So 12S would be tapped here, 16S would be tapped here, right? So that rotary switch will also select where I'm tapping the DC side to get the voltage I want. So through a single rotary switch, I'll turn on power supplies, I'll tap the DC side where I want, and then of course all this stuff will go through the resistor bank, and it'll still use this little rocker switch to switch in and out the current limiting resistors. So big rotary switch, switch in and out power supplies, and I can go anywhere from 12S to 36S just by flipping a switch. So this will be a really nice, like I said, supercharger, more or less 30 amps, and with a huge voltage range, so I can charge pretty much everything I will ever run across. Well, anyway, this is De-bodgery saying, hey folks, watch out for that SARS virus. Don't let your body get sick with COVID-19. Be nice to each other. Treat each other with decency and respect. Good grief, this world is a pretty shitty place. Let's start making it nicer. Talk to you later. Bye.